Hello friends, welcome to my channel. We have given a problem of limit. This problem has been asked in JEEM in 2023, and we have given problem that let A1, A2, A3 dot A and B n positive consecutive terms of an AP. If D is greater than 0 is common difference, then we have to find out the limit n tends to infinity square root D upon n bracket 1 upon square root a1 plus square root a2 plus dot plus square root of 1 upon square root of an minus 1 plus square root of an. So we are going to find out the given limit. So first of all, we are going to rationalize. We have given limit is, so we have given limit n tends to infinity square root d upon n, and this is 1 upon square root a1 plus the square root a2 plus the square root of a2 plus the square root of a3 plus dot plus the square root of an minus 1 plus the square root of an, and we have to find out the given limit. So 1 upon square root a1 plus the square root a2 can be written as square root of a1 plus the square root of a2 into a square root of a2 minus the square root of a1. We can multiply with this quantity, so this becomes a2 minus a1, and this is a square root of a2 minus a1, and this is a square root of a2 square minus the square root of a1 square. So this is a square root of a2 minus the square root of a1, so this can be written as a2 minus a1, and we know that the difference between any two consecutive terms or succeeding term to preceding term is common difference. So this is equals to a2 minus a1 upon d, since we know that an equals to a1 plus n minus 1 into d. This is the nth term of, this is the formula for nth term of AP. So similarly, we for any k, for any k lies between to n, this can be, we have formula that square root of ak plus square root of ak plus 1 is equals to 1 upon square root of, this can be, this is equals to square root ak plus 1 minus square root of ak upon, so this is ak, this is, sorry, this is d. So using this substitution, we are going to write the limit is limit n tends to infinity square root of d upon n. This is equals to square root of a2 minus square root of a1 upon d, again square root of a3 minus square root of a2 upon d, and this is square root of an minus this is an minus 1 upon d. So sorry, by adding this, by simplifying these terms, this becomes limit n tends to infinity square root of d upon n, and this is, we can add this as very simpler formula, square root of a2 minus square root of a1, this is square root of a3 minus square root of a2 plus this is square root of an minus square root of n minus 1. So we are looking here that square root a2 gets cancelled. So after summing these two terms, after addition of these two terms, we are getting a square root of a3 minus square root of a1. So continuing this way, this last term getting out to be cancelled, and we are looking here that we are remaining only a square root of an. So we are getting only limit n tends to infinity a square root of d upon a square root of n, sorry, this is a square root of n. So and this becomes a square root of an minus a square root of a1. So this is d. Again we can write here that this is a1 plus n minus 1 into d. This is the formula for the nth term of ap. So our limit is, so this limit becomes limit n tends to infinity a square root of d upon n a square root of, so this is, we can write this as, since d is positive, so the square root d is defined, so this gets out to be cancelled and this becomes nd, the square root of nd, and this becomes a square root of a1 plus n minus 1 into d, and this is a square root of a1. Now we can define by this quantity as a square root of n. So limit n tends to infinity by dividing a1 upon a square root of n. This becomes n minus 1 upon n d, and this is a square root of a1 upon n square root of, and this is the square root of d. So again, limit n tends to infinity the square root of a1 upon n, this is 1 d minus d upon n, and this is a square root of a1 upon n upon a square root of d. We know that, since we know that this, if n tends to infinity 1 upon n tends to 0, so by this term becomes 0 and this is also becomes 0, so our limit becomes the square root of 0 plus d minus 0 upon a square root of d. So this becomes a square root d upon a square root d, and this is 1. So answer of the given problem is 1. So we have solved this problem of the given limit. Thank you.